Okay, today we're going to talk about direct and inverse variation involving squares. Now, we talked about direct and inverse variation before, and just a quick reminder, if it is direct variation, you're going to make a proportion that's going to look like this. Y over x is equal to y over x. These are x sub 1 and these are y sub 2. Okay, so it's going to look like that if it's direct. If it's inverse, it's going to look like this. X sub 1, y sub 1 equals x sub 2, y sub 2. Okay, so when it says direct, you're going to write it underneath, and when it says inverse, you're going to write it next to it. And what I do is I just write in words, first of all, what the relationship is, and then I go back in and plug in the numbers later. Okay, so a quadratic direct variation is a function defined by an equation of the form y equals kx squared. Okay, now think about this. If we're solving for k, it would look like this. Okay, which is where we get our proportion from, where k is a non-zero constant. You say that y varies directly as x squared, or that y is directly proportional to x squared. So here's the proportional part. Okay, given that a varies directly as the square of d, so a varies directly as the square of d, and a equals 45 when d equals 3, find the value of d when a is equal to 60. So this is where we're going to put our proportion in. Okay, so a is going to go on top. So the first time we have a is 45 when d is 3. So 3 squared goes on the bottom. The second time we have a is 60, and we're looking for d squared, okay, which is why we're doing this in our quadratic equation section. So let's go ahead and simplify this. So this is 45 over 9 equals 60 over d squared. 45 divided by 9 is 5. So 5 is equal to 60 over d squared. I'm going to multiply both sides by d squared. So I get 5d squared equals 60, and then I'm going to divide both sides by 5. And come up here. So d squared is equal to 12. So then I'm just going to take the square root of 12, and I'm just going to keep the, I'm just going to assume that they want the principal square root. So I'm going to simplify this. I can write it like this, 4 times 3. So d is going to equal 2 times the square root of 3. Okay. The reason I keep it in radical form is because they didn't give me any information about this. This is not technically a word problem. It's just a computation. So I'm going to keep it in radical form. If I have a specific word problem, I might put it into decimal form. So if this were decimal form, I would say that's about 3.5. If I take the square root of 3 and multiply by 2, that's what I would get. Okay, so that is what direct variation with a square is going to look like. And they will tell you what thing is being squared. Sometimes it's the top number, sometimes it's the bottom, sometimes it's both. Okay, so then an inverse variation as the square is a function defined by an equation of the form x squared y equals k, where k is a non-zero constant, or y is equal to k over x squared. Okay, so this is where we get our proportion from, and x cannot be 0. You say that y varies inversely as x squared, or y is inversely proportional to x squared. Okay, so let's look at example 2. Given that h varies inversely as the square of r, so h varies inversely as the square of r, and that h is equal to 2 and r is equal to 3, so 2 times 3 squared, find the value of r when h is equal to 3/10. So that's what it's going to look like. We would have hr squared. Okay, that's for inverse. So then I'm going to solve for r squared. So I have 2 times 9 equals 3/10 r squared. This is 18. I'm going to multiply that by 10 over 3 equals r squared. So this will cancel, and I get 60 is equal to r squared. So r would equal the square root of 60, which would be, I can factor out of 4 times 15. So that would be 2 square root of 15 is equal to r. And if this was a word problem, I would find the decimal equivalent. It's about 7.7. Okay, so let's look at now one more thing. And this says, remember that in each particular situation, you must examine each root to see if it makes sense. Okay, so if you're given a word problem, you do want to check to see whether you can have both a positive and a negative root or just the principal square root. So you do have to kind of think about that. All right, so here we have m varies inversely as the square of t. So if m varies inversely, we have m sub 1 t squared sub 1 equals m sub 2 t squared sub 2. Okay, so that's what that's going to look like, because m varies inversely as the square of t. So when m is 45, t is 1.2. Don't forget to square that. Find the value of t when m is equal to 20. Okay, so this is my equation. So I'm going to square 1.2, which is 1.44. So I have 45 times 1.44 is equal to 20t squared. If I multiply that times 45, I get 64.8 is equal to 20t squared. Divide both sides by 20. And t squared is equal to 3.24, which is a perfect square. And if I take the square root of both sides, it's going to be equal to 1.8. Okay, so that's how we do those particular problems.